The other thing we're going to integrate over is a cylinder. Now the cylinder, the coordinates use the circular polar coordinates that we've seen previously, that each point in the cylinder can be given by three coordinates. One, the distance from the central axis, that's the r. Theta then is the angle, if you project down, the angle that it makes with the positive x-axis, and then finally the height. Okay, as before, just like before, if you're working with, if you've got stuff in terms of x, y, and z, x is equal to r cos theta. You can see this in last week's lectures. And y is equal to r sine theta. And z is obviously just z. Now, the thing here is, what is the volume element going to look like here? So, for example, we're going to do an example in a moment where, well, we're going to talk about this. What the hell does this mean? We're going to find the mass of this. We've got a density x squared z. We're going to, well, when we talk about what shape this is, it's going to be a cylinder. We're going to convert the x into what are called cylindrical coordinates, the r cos theta, but the dv is a small issue. So we'll go on to the next page. So the dv is really a little pineapple piece. So this is supposed to be sitting inside a bigger kind of cylinder. So maybe something like, this is a way of chopping up the cylinder. What you can do is take the cylinder, chop it height ways, and that do with a small width of height, if you know what I mean, dz. Then how you do it, so you got all these circular discs as such. Then what you're going to do is you're going to chop them into, so chop one is chop into discs with a height of dz. Then what you're going to do is you're going to take these discs and chop them up into loads of these pizza slices. So then all of these make up an angle d theta, and then finally what you do for the final chopping, you take you chop it up like this, and these, the width of these is dr. So then if you chop up the cylinder, you get these pineapple pieces. So if you imagine, like if you do the chopping, these chops, the radial chops first, you're going to have a load of pineapple slices. And then how do you slice up the pineapple? So suppose you do that. So you get a little pineapple slice, and you chop this up. Now all these should be way smaller. You're getting bits of pineapple. So the dv is a little bit of pineapple. Now what we would have shown in last week's lectures is that this here, the area of this is equal to r dr d theta, and therefore the volume is r dr b theta, the area by the height. So you get this. Okay, this is something that you kind of have to know going off the bat. So it's whenever you're using this circular coordinates, in this case they're kind of called cylindrical, the area here is r dr d theta, and then if it's a volume element, it'll be r dr d theta by dz. You can do this with other shapes, spherical coordinates and stuff, but we're just going to work with boxes as we saw in the previous lecture, and cylinders as we're seeing in this one. Okay, right, back to the previous page. So what the hell is this? Well, this is saying that in terms of the x and the y, you got x squared plus y squared less than or equal to 3 squared. And we saw in last week's lectures that this corresponds to a disk of radius 3. So this bit is a disk of radius 3. That's from last week. And we know that the height of this thing, the z coordinate, goes between 0 and 2. So the x coordinates the x/y coordinates together make a circle, but then the height goes from 0 to 2, so you got all these circles going from z equals 0 to z equal to 2. So this is a cylinder with a radius of 3 and a height of 2. Okay. So what we're going to do here is how we're going to find the mass of the cylinder. And there's loads of different options, but the one we're going to look at, the one I'm going to recommend is, first you fix a height and a specific angle. So if I throw the y-axis there, so there's x-axis there, something like that. Oh, this picture is not good. So take a fixed height, which we've done, and a fixed angle. Now the fixed angle, this picture is not good, is theta. And what you're going to do is you're going to find the mass of a spoke. Now this drawing is just terrible, but what I mean by a spoke is something that goes from the center out to the edge. So it's like, yeah, a spoke of a wheel, something like that. And we're going to find the mass of that. So this is fixed height, in other words z, and a fixed angle theta, and we're going to find the mass of the spoke. Maybe the first thing we should do is just, before we do that, the rho xyz dv. So the rho xyz is the density at a point xyz times dv. We're going to convert this to cylindrical. So the density is x squared z, and the volume is, so we need to know that for cylindrical coordinates, it's r dr d theta dz, and all that remains to do is put the x in terms of these, and x in these coordinates is, it's up the top of your page there, r cos theta. So this is r cos theta squared z r dr d theta dz. This is the thing we're adding up. What this is the mass of a pineapple piece, because this is adding up the mass of all the little pineapple pieces. Okay, now we can do a little bit with this here, for careful if you have the space. So r cos theta by r cos theta will be r by r gives you r squared, and there's an additional r here, so that's r cubed. Then you've got cos theta by cos theta is cos squared theta. There's a z knocking around, and then you've got your dr d theta dz. Okay, let's find the mass of a spoke at a fixed angle and height. That should say z, not r. Okay, so looking at this spoke, if you remember from last week, that r is the distance to the central axis. So in the middle is r equal to 0, and the outside is the radius of the cylinder, which here is 3, which we know from here. So the mass of a spoke, we are going to add up from r equal to 0 to r equal to 3 the mass of the pineapple pieces. So if you imagine the spoke there, if you cut the spoke up into little pieces, it's just a load of these pineapple pieces. And the mass of a pineapple piece is here. So we got r cubed cos squared theta z dr d theta dz. Now along the spoke, the angle is fixed and the z is fixed, so both cos squared theta and z can be taken out as constants. You can, I'm taking these out all the time, I think it helps understand what's going on, but you can actually just fix them here as constants rather than fixing them outside. So you get cos squared theta times z. Now let's think about d theta and dz. If we look again at the pineapple piece, as you go along, the d theta is fixed. This angle here is fixed. This is actually pointed in the wrong place. This should go there. And the dz is fixed. Because, yeah. So d theta and dz are also fixed. And so you're left to add up from 0 to 3 r cubed dr. And that's just a normal integral. Antidifferentiate as normal. So the antiderivative r cubed with respect to r is r to the 4 over 4. And do your substitute top limit minus substitute bottom limit. There's definitely ways to do less writing here than I'm doing. But yeah, So cos squared theta. In fact, it's actually possible to do this integral, do all the integrals simultaneously here, but I think it's just safer to do it this way. It makes more sense. Oh, I'll find the mass of a spoke, then what'll I do? So top limit is 3, so I have 3 to the 4 over 4 minus 0 to the 4 over 4. Remember, you can pause the video whenever you want. And if I look at this, 3 to the 4 is 81 divided by 4. Cos squared theta z d theta dz. And what this is the mass of a spoke at a height z angle theta. Now if we add up the mass of all the spokes as you go around from an angle of 0 here and add up all those spokes from theta equal to 0 through 180, bigger than 180, all the way to 2 pi, you get the mass of a disk. My drawing is so bad, I'm sorry. So you've got the mass of a spoke, add up all those spokes from theta equal to 0 here up to theta equal to 2 pi, and then you will find the mass of a disk. So we'll do that on the next page. So the spoke goes from 0 to 3, so we calculate, we've already actually done that. So now where we can pull out the z terms is they're constant. Yeah, so along the disk, so dz would be actually the height of this disk, which is constant the whole way around, and z is its height, so that's constant. So we're going to add up all of these from theta equals 0 to 2 pi, and all the z stuff is constant. So we have that the mass of a disk is equal to add up from the theta equal to 0 spoke to the theta equal to 2 pi spoke, and the mass of each spoke is 81 over 4 cos squared theta z d theta dz. And we're saying that theta is changing, but z is fixed, and so dz is fixed as well. So I can take out my constants. 81 over 4. Now cos squared isn't a constant, it's changing, it's going between 0 and 2 pi. Z is a constant, dz is a constant, and I'm left to integrate from 0 to 2 pi cos squared theta d theta. And thankfully this integral is given in the question. The integral of cos squared from 0 to 2 pi is just equal to pi. So I have that the mass of a disk is 81 over 4 z dz times pi. So that's the mass of a disk, and all we have to do now is add up the mass of each of the disks from z equal to 0 here up to z equal to 2. So the mass of the cylinder, add up from z equal to 0 to z equal to 2, the mass of the disks, which is 81 over 4 z dz by pi. Now here I won't bother bringing out the constants, I'll just fix them in the antiderivative. So if I'm antidifferentiating 81 over 4 pi by z, I can fix the constant 81 over 4 pi, and then the antiderivative of z with respect to z, well z is z to the 1, so this would be z squared over 2, and we're going from 0 to 2, and now we do top limit minus bottom limit. Doesn't say anything about SI units here actually. So we get 81 over 4 pi, and now top limit minus bottom limit. So we're going to have 2 squared over 2 minus 81 over 4 pi by 0 squared over 2. Talking top limit minus bottom limit. Top limit in for z, 2 squared over 2 minus bottom limit, 0 squared over 2. So this looks like 4 over 4 is 1. So we have 81 pi over 2. You could approximate that if you wanted. Remember, if you're doing any approximation, I want to see 4 significant figures. So I get 81 pi over 2 equal to 127.2. I can't say that it's definitely kilograms. I don't know. There's nothing said about the units here. So that's everything. All done.